So hi guys, I am Jamaica Esmanyabo and I am from BS FT2M1. And in this video, I am going to perform my PIT in this subject, which is Calculus in Food Technology. So I am going to choose one problem in each given topic of our teacher. So our PIT is solve one integral yielding exponential, log, transcendental functions, inverse, hyperbolic functions, and one application of integrals, and explain it in a creative way. So since I'm not a creative person, I'll try to explain it in a very creative way. So let's go. So these are some of the formula that we can use in our given problem or chosen problem. So we're going to solve for integrals yielding inverse hyperbolic functions. So from the title itself, it means if we're going to integrate an integral, the answer will be inverse hyperbolic functions. For us to illustrate the formulas for integrals yielding inverse hyperbolic functions, let's solve for an example. We have here the integral of dx over square root of x squared minus 6x plus 13. Okay, if we encountered a square root of trinomials in the denominator and the highest exponent is square, the first thing to do is try to complete the square. So it's going to be integral of dx over square root of x squared minus 6x. For this square to be completed, let's divide the numerical coefficient of x, which is 6 by 2. So, negative 6 over 2 is divided by 2 is negative 3 squared. So we have dx over square root of x squared minus 6x plus 9. And for the constant, let's add the 13. Let's add the 13. And then minus 9 for the equation to be balanced. Now it's going to be the integral of dx over the factor of this one, which is x minus 3 squared plus the constant right here, which is 13 minus 9 is equals to 4. So the integral of dx over square root of x minus 3 squared plus 4. So what integral formula can we use in this equation? We have here the plus. We can use this formula, which is integral of du over square root of u squared plus a squared. Let u is equals to x minus 3 because the constant here is not 1. We will use this formula. Our a here is 2 because we need du in the formula. So let's differentiate u with respect to x. So du is equals to dx. Now we can substitute, or let's substitute. Dx is simply the integral of du over the square root of u squared plus 2 squared. So our formula here is arcsin of u over a. Therefore, the final answer is arcsin x minus 3 over 2 plus c. Or we can also use this form right here, which is ln x minus 3 plus square root of x squared minus 6x plus 13 plus c. Now let's proceed to the area between two curves or application of integration. Find the area of the region enclosed by the parabolas y is equals to x squared and y is equals to 2x minus x squared. Let us sketch and understand the scenario. Y equals x squared is a parabola which is opening upwards, and 2x minus x squared minus means it's going down. One at 0, and the other one is at 2. So it's a parabola that opens downwards. we need to figure out this area right here between the curves, and we have two functions here, and we need to find the area in between this. And what we need to figure out first is the point of intersection. The two curves are x squared and 2x minus x squared. So bringing them together, on the left side, we get x squared plus x squared minus 2x equals 0. So we have 2x squared minus 2x equals 0. 2x is a column, so we get x minus 1 equals 0. That gives you 2 points, which is x is equals to 0 and x is equals to 1. If I put 0 right here, so the value of y is 0. And if I put the 1 right here, the value of y is equals to 1. So we get 2 points, and as expected, one of them is the origin and the other one is 1, 1. So we have this point, which is 1, 1 in the origin. Now, to find the area, we need to subtract the area of the region between the two curves. Let's find what is the difference between the curves. y2 minus y1 equals 2x minus x squared minus x squared will give us the region in between the two curves. So that region is equals to 2x minus 2x squared. Therefore, the area now is equals to the area between the curve. When x varies from 0 to 1, and the curve in between will be 2x minus 2x squared times dx. Now let's integrate. The integral of 2x will be 2 multiplied by x squared over 2 minus 2 multiplied by x cubed over 3. That varies to 0, 1. So that gives you x squared multiplied by 2 over 3 x cubed between 0 to 1. So this is 1 minus 2 over 3 minus 0 equals to 3 minus 2 over 3. That will give us 1 over 3 unit square. So that is the final answer.